Hi everyone, today I'm going to be doing homework number 1, problem 28. And the problem goes, a sound wave with intensity 2.0 times 10 to the negative third watts per meter squared is perceived to be modestly loud. Your eardrum is 6.0 millimeters in diameter. How much energy will be transferred to your eardrum when listening to this sound for 1 minute? So right off the bat, we know 3 things. We know that intensity equals 2.0 times 10 to the negative third watts per meter squared. We know our diameter is equal to 6.0 millimeters, and we know time is equal to 1 minute, which is 60 seconds. Awesome. And the question asks, how much energy will be transferred to your eardrum? So we are looking for E. So there are going to be 2 main equations that we will use to solve this equation. The first one is E equals P times T, which is energy, equals power times time. So that's our first equation. And so we're looking for E, so it's in the right form. We have a value for T, and we just need to solve for what P equals. And that's where our second equation comes into handy. And our second equation is I equals P divided by A. So intensity equals power divided by area. That's equation number 2. And so we want to find the value for P, so let's multiply A over to get P equals I times A. And A in this case is the area of a circle. And the area of a circle is pi r squared. And we know the value of r because we are given d, and d equals 2r. So we have 6.0 millimeters equals 2r, giving us 3.0 millimeters equals r. And so let's take millimeters and convert them to meters. So r equals 3.0 millimeters times 1 meter divided by 10 to the third millimeters. So that gives us a value of 3.0 times 10 to the negative third meters. Awesome. So now that we've solved for P, we can plug it back into our main equation. So it's equation 1, and our equation 1 is E equals P times T. And so since we know P, we can say E equals I times A, and A in this case is pi r squared times time. And so let's do a quick check. We're still looking for E, so it's on the right side of the equation. We have a value for I, we now have a value for R, and we're given a value for T. So let's start plugging in our values. So you get E equals intensity, which is 2.0 times 10 to the negative third watts per meter squared, times pi times r squared, which is 3.0 times 10 to the negative third meters squared, times 60 seconds. Okay, and if you plug that into a calculator, you get the answer to be 3.4 times 10 to the negative 6 watts per second. And that simplifies down to 3.4 times 10 to the negative 6 joules. So, back to our question, it takes 3.4 times 10 to the negative 6 joules of energy to transfer the sound to your ear. Awesome. Thank y'all.